Dear students, in the last session, I had explained the thevenins theorem, but in this session, we'll do some problem on thevenins theorem. To find the Thevenin equivalent of a given network, first consider the given network. Step 2, remove the load resistance and calculate the voltage at the load terminals, that is VTH. Step 3, by looking back from the load terminals in the network, by replacing the voltage source by internal resistance and current source by open circuit, we can find the equivalent resistance, that is RTH. Step 4, replace the entire network by simple Thevenin source of voltage VTH and a Thevenin's resistance RTH connected in series with it. Problem. Using Thevenin's theorem, find the current through 4 ohm resistor in the following network. And voltage across the load. So, this is the given network. Step first, consider the given network. That means consider the given network. This is the given network. Step 2, to find the Thevenin's voltage, remove the load resistance by open circuit in which the current is to be found and find the open circuit voltage which appears across the two terminals. That means at the A and B, where the resistance has to be removed. That means VO, that means output voltage at the two terminals A and B. VO equals I into R2. I means the current I is flowing in this mesh is I. Therefore, I equals E divided by R1 plus R2. That means I equals E divided by R1 plus R2. VO equals 8 volts, E equals 8 volts divided by R1 plus R2. That means 1 plus 1 into 1. R2 equals to 1 ohm. VO equals 8 divided by 4. 8 divided by 2. That's equals to 4 volts. That's equals VTH. That means the output voltage is equals to Thevenin's voltage. Like this, we can calculate the Thevenin voltage. Step 3, find the equivalent resistance. No. Yes, VTH. Like this, we can calculate the Thevenin's voltage. As the load is open, there is no potential difference, potential drop across the R3. Therefore, the potential difference between the terminal A and B is the same as that between X and Y. So, this voltage is called Thevenin's voltage. Step 3, find the equivalent resistance. That means Thevenin's resistance RTH by looking back from the load terminals in the network by replacing the voltage source by internal resistance and current source by open circuit. This circuit can be extended like this. That means The terminal A and B is stretched. It looks like this. The resistances R1 and R2 are connected in parallel, and these two resistances are connected in series. So RTH equals R1 parallel R2 plus R3. So RTH equals to, you know, the R1 into R2 divided by R1 plus R2 plus R3. So that is equals to 1 into 1 divided by 1 plus 1 plus 2 ohm. R3 equals to 2 ohm. That's equals 5 by 2. So that's equals to 2.5 ohm. Step 4. Replace the entire network by a simple Thevenin source of voltage VTH and a Thevenin resistance RTH in series with it. Step 5. Finally, by connecting the load resistance across the terminals A and B and calculate the current through or voltage across the load. That means IL is the load current. Therefore, IL equals to VTH divided by RTH plus RL. Therefore, IL equals 4 divided by 2.5 plus 4. 2.5 plus 4. That's equals IL equals 8 divided by 13. That's equals 0.615 amp. Therefore, VAB equals IL into RL. So VAB equals 0.6515 into 4. That's equals 2.46 volts.